So in previous sections, we've been given an equation and we've been graphing it and we've seen the equation now in different forms. Now we're going to work on basically writing an equation for a particular relation or graphing it based on given information. So the first example that is given is finding the particular equation of the linear function with the slope equal to -3/2 and containing the point that's going to be the symbol for point 7, -5. So since we're given slope and a point, the easiest form to write this equation is going to be point-slope form. Remember that point-slope form is y minus y1 equals m times x minus x1. So the first, since the y coordinate of the point given is -5, and we want to be able to plug in -5 to this equation and get 0, y1 is going to have to be +5. So basically the signs are always going to have to change because we want it to equal 0. So to write this equation, it's going to be y plus 5 equals m, which is the slope, -3/2 times x minus 7. At this point, we're actually done because the problem did not ask to write it in slope-intercept form. It just wanted an equation. So if you were asked to write it in slope-intercept form, you would just distribute the -3/2, then move the 5 over in order to get y by itself. So for this problem, we want to write the equation that contains the 2 points, -4, 5, and 6, 10. So the first thing we're going to have to do is find the slope. Finding the slope we can actually use with just the definition of slope here, which is m equals y2 minus y1 over x2 minus x1 using these 2 points. So that is going to be 10 minus 5 over 6 minus -4, which is going to be 5 over 10, which is 1/2. At this point, we now have the slope and 2 points, so we can write this equation actually in 2 ways using either of the points. Using the first point, we would have y minus 5 equals 1/2 times x plus 4. Or the second way, we would get y minus 10 equals 1/2 times x minus 6. Now, either of those equations are perfectly valid for the information given. Okay, so now we're going to talk about parallel and perpendicular lines. So when two lines are parallel, the lines are never going to cross each other or intersect. For that to happen, their slopes actually have to be equal, because if this line and this line had different slopes, they would intersect. So now we know that parallel lines have the same slope. Parallel lines have same slope. Perpendicular lines, on the other hand, so the perpendicular line is going to intersect at a right angle. So for that to happen, the slope has to one, be the opposite, because this slope is positive as it's slanted up while this is negative, but also be the reciprocal, as this slope is actually increasing at a slower rate than this one, so it's going to be the reciprocal. So perpendicular lines have slopes that are opposite reciprocals. So if if one line has a slope of 2/3, then when I say the opposite reciprocal, I mean that the line perpendicular to this line is going to have a slope of -3/2. So now we're going to find the equation of a graph that goes through the point -2, 7 and is perpendicular. This symbol means perpendicular. It's perpendicular to the equation the graph 3x plus 4y equals 72. So first, we need to figure out what the slope of this line is going to be so as to find the opposite reciprocal to find the slope of the equation that goes through -2, 7. So to find the slope of this, we need to first put it into slope-intercept form so we can see the slope. So we need to get y by itself, so we're going to have 4y equals -3x plus 72. At which point we can divide by 4 on both sides and we'll get y equals -3/4 x plus 18. So then we know that the slope of this line is going to equal -3/4. So the slope of the line we want, the new line, is going to be +4/3, the opposite reciprocal. At this point we have the slope and this particular point, so we can use point-slope form to write an equation, which is going to be y minus 7 equals 4/3 times x plus 2. Now if we wanted to put this into slope-intercept form, we would just distribute in the 4/3 and move the 7 over and solve for y. So we're going to want to find the equation of the horizontal line through the point 7, 8. So let's first just graph this point on the coordinate plane to kind of get an image about what this graph is going to look like. So it's at 7, 8, which is going to be approximately right here. And we want the equation of the horizontal line that goes through this. Now, remember that the general form of a horizontal line is going to be such that sort of like y equals k, where k is a constant. It's just going to be y equals a constant. And that constant is going to be the y value that this always equals, which is this y value, which is 8. So the equation of this is just going to be y equals 8. Now the reason that's the case is since it's a horizontal line, so we can plug in any value of x here, and we're going to get 8 as the y value. So now we're going to find the equation of the vertical line through the point 7, 8. So let's first just look at that point on the coordinate plane again. So it's going to be somewhere up here, and we want to find the vertical line that goes through that point. This is x and this is y. So remember that vertical lines are given in the form of x equals a constant, which in this point is just going to be the x-coordinate, which here is 7. So the equation of this graph is going to be x equals 7. So the exercises of this section have to do with practicing writing equations when given information about the graph. So we need to use those techniques of putting it into either point-slope form or any form that is asked with information that's given, such as if the line is parallel to another or perpendicular. So you need to use those concepts to write equations.